actual variable terms will not change. If you remember order of operations, PEMDAS, right? Add is two lower than exponents. It's not strong enough to change exponents. So add and subtract will never change the exponent. Right? We only can combine the coefficients. So, really basic example. 3x plus 5x. I can just combine the coefficients. 5 plus 3 is 8. The variable stays the same. If I use this example up here, again, we said those are like terms. They both have x and y. They both have 1 squared on y and it's just x. So they're like. So I can combine the coefficients, 8 plus 4. Does it make a difference what I've hit put next?
Has to be y.
Does it? Can I put y squared first, or do I have to put x first?
Doesn't matter. Don't matter.
It don't matter. You'll see me default to alphabetical order, but it doesn't matter. If you put 12 y squared x, you're still right. Either one of those is fine. If you determine that they are alike, you can put either one and you combine them. But I cannot change the powers. A common mistake I'll see is for this one, people will put, if you can't, add cannot change powers. Remember, we learned those exponent rules. I have to multiply variables to change their power. And adding and subtracting won't. So, for another example, let's say if I have this. And I said, hey, combine that. And simplify that. It's not always just going to be one term. Right? So here I have 8x plus 7 minus 3x minus 4. And I say, hey, let's combine these. We're looking for the like terms. So 8x and 3x are like. 8x minus 3x is 5x. And then constants can combine, but you have to be really careful when you look at the middle operation. 7 minus negative 4. Minus negative is plus. So 7 minus negative 4 is 7 plus 4. So I'll end up with 5x plus 11. That's the simplified version. Are you following? Does that make sense? Just look for the things that are alike, combine them. Once I'm at the point where the things that are left aren't alike, I'm done. So 5x and 11 have nothing in common. They're not alike. So I'll just leave it. Are there questions about that before I go to this last thing? Okay. The last thing is, how do I combine, multiply, and add? And the rule is, if I have something times and parentheses that includes add or subtract. Okay? Every one of you has seen this, but we're going to find it again. The distributive property says I can take the thing on the outside and multiply it by the things on the inside. I can basically leap it over addition and subtraction. Multiplication can do this over add, subtract. It cannot do it over multiply or divide or anything higher. If the parentheses itself has an exponent, it doesn't work. Right? You have to clear the exponent first. But if it's just add and subtract on the inside, I can multiply it in. So, for an example, let's say I've got that. And I say, hey, I want to simplify this. Since it's multiplied to the parentheses, this 8 can be multiplied inward. Okay?
And this one, sorry, I want complex.
Yeah. Whatever.
We're drawing circles in there, so I thought
Oh.
that's not helpful.
If you want, that box right there has a It's these two combined together, yeah. In that big old box down there, there's a bunch of them. Go ahead, Becky.
Okay, so sorry to interrupt.
You're good.
This is exciting stuff.
Okay, so I can multiply this in. Now, when you multiply a number times a variable term, it's just the numbers that combine. Was there not one open already?
Oh, no.
Oh,
Do
I
you
thought
not
there
want me
was.
to open
No, no,
one?
no, you're good. I just thought there was one open already for you. So 8 times 2x, 8 times 2 is 16x. Two variables must multiply to change powers. So since I'm just multiplying numbers in, the numbers can combine, but the variables will stay the same. And 8 times negative 7 is negative 56. Does that make sense? The only way the power is going to change is if I multiply two variables. And that stays the same here. If I say, hey, simplify this, I still have multiply going into an add, which is fine. So I can say the same thing. Now what happens is I have x times y. What happens if I try to multiply x times y? Just xy. I can't do anything with it. But what can I do with x times x?
2x.
No, not 2x. If I multiply two variables, remember we did this with the exponents. Two variables means I can add the exponents together. If the variables multiply, the power changes. Multiply changes exponents. Add, subtract does not. Does that make sense? So that would be my simplest version. It's not always the nicest, but it's better than having something multiplied for everywhere. Fair enough? So I'll leave that up top. But let's look at the example problem, and then the rest of the time is there to practice. This says to simplify this right here. It looks complicated, but we're not doing anything new. It's 3 times this parentheses minus that parentheses. So, it's still just add and subtract. The parentheses itself doesn't have an exponent, so I'm good. I can take this 3 into everything. Now, 3 times x squared, it's a number being multiplied, so it's not going to be able to change the exponent. So it's just 3 times 1, which is 3. So 3x squared. 3 times negative 3 is negative 9. 3 times 2xy is 6xy. Do we see that? Now, if you have a minus on the outside of a parentheses, that minus can do the same thing. I can distribute the minus through. All that's going to do is flip everything's sign. If you ever bring a minus in, it's the same thing as multiplying by negative 1. Okay? I'm going to have minus 2x squared plus 3xy minus 8.
Wait, what did you get? What are you bringing over to the other one?
So this one, the negative. Because remember, it's minus the whole thing. And because all that parentheses is doing is holding that minus, right? It's not really doing anything other than saying like, hey, it's minus this. So if I bring the negative in and I bring that 3 in, the parentheses aren't there anymore. They're not doing anything. Now I can look at what's alike. Right? This has x squared. That has x squared. 3x squared minus 2x squared is just x squared. Or 1x squared, but we don't write 1. We've got constants. Negative 9 minus 8 is negative 17. This has xy, that has xy. They're like 6 plus 3, 9. So I have 9xy. That's my simplified version, because now nothing there has like terms. One has x squared, one has xy, one's a constant. Does that make sense? So the rest of the remaining time is yours to work on the 4 practice problems I put there. It's a kind of like a comprehensive review of all the stuff we've done so far. Go ahead and work on that. You can work together. Let me know if you've got a question, but the rest of the time is yours to work on that. Did I answer the question? Okay. I'll be in there later.